The directions say to expand the logarithmic expression below as much as possible. That means I want to break this up into separate logarithms. When I look at this problem here, the first thing I see is I've got a square root. When I'm doing these properties of logarithms and working with roots, I really want to think of roots as rational exponents. Remember, there's really a little 2 as my index here. So that's a square root of x. Remember, roots then, the index of the root, the little 2 there, becomes the denominator of the fractional exponent. So if I rewrite this, I'm going to have log base d. I'm going to get x to the 1/2 power. Remember, that's the same thing as the square root of x, times y to the 3rd power over z to the 2nd power. And now when I look at this, if I'm going to break this apart into separate logarithms, I have to figure out what type of expression is that whole thing there. And what I can do is imagine putting numbers in for x, y, and z, and then thinking about what would be the very last thing I would evaluate. So if I put a number in for x, and for y, and for z, I'd have to take the powers first. I'd have to take x to the 1/2, I'd have to take y to the 3rd, I'd have to take z to the 2nd. Then I would do the multiplication in the top, and I'd figure out what that is. And then the very final thing I would do would be to take the top and divide by the bottom. So this right now is a division problem. It's a quotient. And to do a quotient, I take the log of the top and I subtract the log of the bottom. So I'd get the log base d, and I'd have x to the 1/2 times y to the 3rd power, and then I'd subtract and get the log base d of z to the 2nd power. Now for both of these logarithms, they can be broken down farther, so I want to do it as much as possible, like it says there, right? As much as possible. So I'm going to keep going in this problem. Right now, this first expression, if I put in numbers for x and y, I'd have to take x to the 1/2, and then I'd have to take y to the 3rd, and the last thing I would be to do would be to multiply. So that's a product. So I'm going to have to rewrite that as the sum of two logarithms. The last thing here, when I look at the second logarithm, that's the log of something to the 2nd power. The log of something to a power, that power comes down in front. So the first logarithm is going to become a sum. So log base d of x to the 1/2 plus log base d of y to the 3rd minus, here I can bring the 2 down, log base d of z. And now with these first logarithms, I've got log of something to a power, so that power can come down in front. So that's a log of x to the 1/2. Not a very good 1/2, I realize, but we bring the 1/2 down in front, so we'll get 1/2 log base d of x. We'll bring the 3 down, plus 3 log base d of y, and then this just comes down again as well, minus 2 log base d of z. And now I've got simple logarithms, just the log of x, the log of y, the log of z. I can't expand those anymore, so that would be my solution.